the 8.7 practice part of the notes. We're going to start with that one on the bottom here, number 1. The hardest part is usually just drawing the diagram properly, making sure you're reading everything and then able to draw it properly. So it says a dog is looking at a squirrel at the top of a tree. So I'm not going to draw a dog. I'm just going to say, here's my dog looking up at this tree, and the squirrel, because the squirrel's at the top of the tree. So here's a squirrel on top of this tree that we're going to draw straight down. Again, you can draw nice pretty pictures and all of that. I'm just going to kind of label it like this for now. So we have our squirrel at the top, the tree, and the dog on this side. So now let's keep reading to kind of label some more of this. So it says the distance between the two animals is 55 feet. That means this distance directly. Otherwise, if it was referring to this bottom distance here, it would say something like the horizontal distance, or from the dog to the tree, something like that. Whereas if it's telling us it's directly between the two animals, these two animals, it's got to be that 55 feet. And then it says the angle of elevation. Angle of elevation is when you look up at something, because a dog is looking up here. And remember that all angle of elevations and depressions are measured from the horizontal line. Well, here's a horizontal line, and this is the dog looking up. So this angle down here is 64 degrees. How high is the squirrel? So this is going to be that X we're looking for. And how far is the dog from the base of the tree? So we're kind of going to eventually find both X and Y, but you want to start with one of them. So kind of just ignore that Y for a second, and let's just work with finding X first. Sorry, let's get this clear. Okay, here we go. So to find the X, this is our opposite side, and this was the hypotenuse. So I want to use sine of 64 equals X over 55. You want to multiply by 55, and that will help you find your X. So grab a calculator, and we are going to round. It says to the nearest foot. So once you get an answer here, you're going to round it up or down, depending on what you get. Okay, so this would be 55 sine of 64. Again, make sure you're right in the right mode or in degree mode, and you get 49.43 as like if you were to round this, but we're going to eventually round this up. But I'm just going to write this part of it, 49.43, and so that rounds up to 49 feet if you round it to the nearest whole foot. Okay, so that's how high the squirrel is up on that tree. Okay, now we're going to move on to finding Y, how far away is the dog to the tree, from the base of that tree. So we want to find Y this time. You have a couple of choices. You can do Pythagorean theorem, or now I want to work with my adjacent side, and this time I would just look at adjacent and hypotenuse. I would probably do it that way, but it's up to you, whichever. If you want to use the new measurement you just got, you can. I just would be careful doing that, because if you made a mistake getting to this point, now your final answer will also have a mistake. But this would be cosine of 64 is equal to Y over 55, because again, the adjacent over hypotenuse. Same thing here, we multiply by 55, grab a calculator, and let's see what it comes out to. So this time it's 55 cosine of 64. And this comes out to 24.1, but again, we're going to round this up to the nearest, or round to the nearest whole number, which is just 24. So 24 feet is how far the dog is from the base of the tree. Okay, so we answered both parts of the question, and that's how we would kind of walk through an example of angle of elevation. Let's see, on the next page, there's still two more. I'll do kind of a setup of both of them, and you can try to kind of finish them up, and we can go through it the next day as well. So we have a 450-foot tall building that's already kind of labeled here, is near a shorter building, and the person on the top of the shorter building finds this angle of elevation to the roof of the taller building to be 25 degrees. So it's, remember, from the horizontal looking up, that is that 25 degrees. But then it says the angle of depression of its base, and, I'm sorry, so he finds that angle of elevation and the angle of depression of its base to be 35 degrees. So again, measured from the horizontal, looking down this time, would be 35 degrees. The shorter building is 270 feet tall, while the taller building was 450, like it said. And then it says how far apart are the two buildings to the nearest foot. So this is like our X. Now if this is the X at the bottom here, even this will be X, because I would probably label something where it's in the triangles that you're working with. So we have a couple of different options here in order to figure this out. If this is 270, that means this is 270. And you can subtract from 450 to find out that this is 180 feet, right? So you can either do this triangle here, the one with the 25 degrees and 180 and X, or you can use the other triangle with the 35 degrees. This is 35 degrees, and it has 270 here with the X. So it doesn't matter which one you use. Both of them, I would probably use tan because it's opposite over adjacent, but you can technically do either one to help you find the X, which will come out to, I'm going to let you guys try this out. So it comes out to 384 feet when you are done trying out either tan of 35 or tan of 25. You can kind of choose which one to set up on that one. And no matter which way you pick it, you will get the exact same answer when you solve them. Both of them do have a variable in the denominator, like X ends up being in the fractions denominator. So you do have to solve it with the division, but still should be able to do this. I'm sorry, it was 386, not 384. All right, and that's it for number 2. Again, if you want to see this in more detail, kind of walking through it, like finishing it up, we can do that in class. I just want you to get an opportunity to try it as well. And then finally, for that last one, I'm just going to draw the diagram, and again, you could try to set it up. So there's a pirate ship that's approaching a coastal village sitting on a cliff where the pirates intend to pillage and plunder. The pirates stop their ship 80 feet from the base of the cliff. So here's a cliff. The village is here. This is the cliff right here. And so there's this right angle where the boat is down, the ship is right here. And this would be then 80 feet of water to get to where the cliff is. And we are looking for this rope because it ends up saying here that the pirates stopped their ship 80 feet from the base of the cliff to avoid running into the coral reef. The pirates have these grappling hooks and 87 feet of rope that they, this is what they have to work with, that they plan to use to climb from their ship to the top of the cliff. But if the angle of elevation from the ship to the top of the cliff is 27 degrees, so this is them looking up at the top, do they have enough rope? So this is kind of like an extension question where first you would find this is how much rope they need, this X. So we would use, in this case, opposite, adjacent over hypotenuse, so this would be cosine. You would find the answer using this setup first. When you have the final answer, it should be enough. The answer they get should be either 87 feet or less. If you end up getting anything more than 87 feet when you solve this, unfortunately, they don't have quite enough feet to work with. Okay, so that's pretty much it for this. And again, when you do solve this, it comes out to like 89.786 if you round that much. And so no, the pirates don't have enough because they were like 2 feet short, a little more than 2 feet short of what they needed. All right, and that's about it.